Welcome, Olivia. We'll get started as soon as some other people join. Probably about 4:02, I'd say. So. Okay, in the interest of time, we'll go ahead and get started. As a reminder, we are recording today's session, and the video will be posted along with the slides on the Computer Science, IT, and Technology Education Moodle. All right, welcome to the CY92 Exploring Robotics 2026 Rollout webinar for teachers. My name is Brent Kern, and I'm one of the education consultants for the CSIT team. So we're going to go over some course information, and the course information can currently be found on the 2026-2027 Future CMS system. So next year, we are launching our new revised CTE career clusters and pathways. We now have cluster groupings, clusters, and then pathways. So this cluster grouping is going to be connecting and supporting success. The cluster will be digital technology and computer science. And then the general pathway for this one will be robotics. But since this is a middle grades course, it really will be in all of the pathways for digital technology and computer science. Course description. I'm not going to read the entire course description to you guys, but I did highlight some keywords. These are written in a language that students, 8th grade students, 6th grade, 7th grade students, and their parents can understand. So imagine someone who has never done anything with robotics. They should understand robots help people. They solve real world problems. They're going to use the engineering design process. They're going to safely build, design, and improve. They're going to do some simple coding. And then their robots are going to move and respond. And then in general, for middle grades, they're going to learn some knowledge, and they're going to gather some skills that can be used in future careers. So general information for this course, effective July 1st. Mike Renee will be the lead consultant for this. The course is obviously starting in pilot status. Since it is middle grades, the proof of learning will be a local determination. All of our middle grades courses have 45 hours of instruction. And since it is a middle grades course, it's not a high school course, it doesn't meet the graduation requirement, but it does meet that middle school elective offering. So it is on that list. So course outcomes. These are the most important things that the student should be able to learn at the end of the course. So for this one, we only have 3. But as a student goes through the course, these are the 3 most important things that they will need before they go to high school, before they enter any pathways. These are our course standards. All of these are written at the B2 or the understand level. That's the RBT that you guys should be teaching at. This was kind of intentional. One is about safe practices and the engineering design process. Safety should be a day one thing, and it should be something we use throughout the entire course. Second standard is to explain the role of robotics and automation in modern industries. So think, how are robots used in the workforce today? That brings us to our career exploration. And then standards 3, 4, and 5, this is the true content of the class. We're going to build robots with mechanical structure. We're going to power them to enable movement. Students should code the controls of the robot so it can do different actions and have different behaviors. And then lastly, we're going to use sensors and data to help robots detect and respond to things in the environment. All right, so now we're going to move into the curriculum guide. So as announced earlier today, you can go ahead and download that document. It is on the Moodle PLC. I've copy and pasted some of that content into the next slide so we don't have to go back and forth between the document and the slides. So the curriculum guide starts out with CTSO alignment. The primary CTSO is going to be the Technology Student Association. They have a variety of events, but if your school offers other CTSOs, there are some events that also align to that are perfectly acceptable. So we have Future Business Leaders of America and Skills USA. The most important thing to remember is that CTSOs are intra-curricular. They're not exactly co-curricular or after school, even though that may be how you run your chapter if you do participate in CTSOs. Any of these competitions can be a direct replacement of course content. That is the main purpose of our CTSOs. They're intra-curricular. You can use those competitive events, modify it for your classroom, and then you now have a nice project with requirements, constraints, and rubrics to use in your classroom. We do have some general robot platform guidance. In general, it will be up to your local school or your local PSU to determine what robot system you will use. But in general, it should be something that you can use safely and made for a classroom or a lab environment. You should be able to have some sort of building component so you can use these steps of the engineering design process. Whatever system you use should have some sort of structure. Think of like gears, motors, and power so that the robot can move. Since this is a middle grade course, whatever system is chosen, it should be block-based coding to control those actions and behaviors. And then we also want some sort of system that will have sensors so that our students can collect data and then they can program things with that data to influence how the robot responds. So we have some general guidance of some popular ones. This list is not exactly all-inclusive. This is just kind of more popular ones, or the ones that I know we currently have around the state. So the first one is going to come from LEGO Education. This is the Spike Prime set. So an important note about this, LEGO just announced, I believe in like the last few weeks, that the Spike Prime system is retiring on June 30th, this upcoming summer. And they're ending their partnership with First LEGO. So, from what I understand, the current competition and the system, you can purchase the system through June 30th. And then their competition with First Robotics, that will go until 27-28. They are working on a new competition for their new hardware. I wouldn't recommend purchasing this, but if you have this, I wouldn't throw this away. I feel like since it is Lego, a lot of parts interconnect with each other. If you find a good deal on this, this may be something you want to purchase to use with their new system. This is their new system. They're calling it the Computer Science and AI Hardware. They haven't announced what that new competition looks like, so I would kind of wait and see what that looks like before you fully jump in and purchase this. Since it is a new product, there may be some things that they have to work out. Another system comes from Parallax. This is the Parallax ActivityBot 360. This is something I would use to supplement with other products. So for example, if I had the Spike Prime system already, I may use this for some of my content, and then I may use some of this for some other content. This robot has a great use of different sensors that students can explore with. And the only issue I have with this system is everybody's robot kind of looks the same. There's no additional things that they can build. They can only build this car model. Another one comes from Pittsco Education, the Tetrix Prime. This is kind of your all-in-one complete system. You're going to get parts, notebooks, resources, controllers, batteries, lessons, curriculum. And then, of course, this is probably the most popular one, VEX Robotics. If you have competitive VEX Robotics, most schools already have a VEX V5 system. They also have the VEX IQ system. That is, I believe, their cheapest entry point. The issue with that one is everything is made out of plastic. I actually recommend the VEX EXP system. It's kind of a middle ground. You have metal components, but it's a much cheaper entry point. And then it's kind of built more for classroom use day to day, whereas the V5 is really built for that competition use. If you have a school or you know of schools around you that participate in the VEX V5 competition, ask them if you can utilize their field elements. Every year, VEX comes out with a new game, and typically they have new field elements. So like in the picture here, it's these red and blue balls, and before it's been different things like rings or jacks, hoops. Every year they have some sort of different element for their competition. So if you know a school that uses those competitions, every year they have to buy the new materials. Well, the old materials, they could be perfectly used in a classroom environment, um, as long as you're not planning on using this for the competition. But of course, any other system out there, all right? I know there's a variety of things out there. There may be something new coming out. If you know of something and you want us to crosswalk it, send it to us. All right, so in our curriculum guide, the bulk of everything, we have different components to help you teach the course. So these are for each standard in the course. The first component is going to be our essential questions. This is one example from the course. I believe over the entire course, you have about 22 essential questions. So think of these as kind of like your big lessons or your units. So this essential question, what common mechanism types in simple machines are used in robots and what do they do? So how do we effectively use essential questions? So start with the question, make it visible, post it as you're teaching, reference to it, have students restate the question in their own words, break it into kid-friendly chunks. So with the previous question, we would need to unpack terms like mechanism, simple machine, and function so that students know what they're doing. As we're doing our learning, let's revisit it, not just at the end, but as we go throughout the class. So you can pause during your activities and ask, what part of the question are we answering right now? Tie every activity back to the question. So after you do a lab or a build session, have students explicitly connect what they did and how mechanisms work. Use it to drive discussion, not just the answers. So encourage students to compare ideas, debate which mechanisms are most effective, and explain why. Require explanation, not just identification. So push students beyond this is a gear to something more like this is a gear. Gears change speeds and torque because X, Y, and Z. End with reflection tied to the question. Have students write, sketch, or explain how their understanding has evolved. And then finally, use it as an assessment tool. Frame this for exit tickets, different responses, project reflections, the things that you actually grade in your class. Use your essential question to help guide that. Then, of course, for every essential question, we have unpacked content. Some unpacked content is much longer than others, but in general, you will have at least this. Our essential question was about common mechanism types and simple machines. So any unpacked content with that major heading A, remember, that is our RBT level. That's the level we should be teaching this to. You can teach higher than that. You can also teach lower than that. But in general, this is the goal. So the remember level. I have two pieces in here. Simple machines used in robot builds, and then common mechanism types in robotics. So if I didn't exactly know what common mechanism types were, I would look at the list here and I can see, okay, I need to teach drivetrain mechanisms, lifting and moving mechanisms, and power transmission mechanisms. And then we break it down even further. So depending on your system, you may see arms, lifts, and linkages, grippers, intakes, and conveyors. Those are just some examples. So you don't have to start from scratch. So when we deliver unpacked content, teach the function, not just the name. So for every mechanism, what does it do? How does it change the motion? How does it change force? Connect simple machines to real robot systems. So we're going to explicitly talk link levers. What do they do? How does that go into arms, pulleys? And then we're going to bring that into our lifts and gears. And then we're going to bring that further into our drivetrains. Hands-on exploration early. Let students see and feel how mechanisms change movement. Ask why and how constantly. Why use gear instead of direct drive? Or you can ask another question like, how does this reduce friction? Chunk the content for students. So those groupings in our unpacked content, those are perfectly good things to group it into. So movement would be your drivetrain, manipulation would be your lifting, and power would be transmission. Have students explain with evidence. So require verbal, written, or diagram-based explanations of mechanisms and action. These are things that they can put in their engineering notebook. Use builds as the assessment. Can students apply the right mechanism for a task, not just identify it? A lot of times it's difficult to use like a multiple choice question in these sort of classes. You can do assessment by just having students build things. Reinforce connections across the lessons. So continuously tie new mechanisms back to the previous ones, and of course, the essential question you are currently teaching. We also include teacher briefs. So for each standard, there's at least a page, if not a page and a half, of teacher briefs. This is kind of written just for you to understand, kind of a focus of how you should be teaching or best practices. So I'm not going to read this out, but this tells us Standard 3 is intended to help middle grade students understand the robot system, and then it goes into what that is. And then, it tells us students are not expected to use formulas or torque, but they should be able to explain trade-offs. So that's kind of the level of understanding that we should be aiming for. Here's another example. This one calls out that, as we have student builds, students should collect simple, measurable data, such as the distance traveled, the time for completion, or the number of successful trials. That's something that they can use in their engineering notebook. That's a data point that they can use to improve their future iterations. So implementing teacher briefs. So this tells us that we need to teach robots as systems. So continuously connect structure, power, mechanisms when analyzing the build. Focus on observable concepts. So emphasize what students can see and test, not the formulas. Explicitly teach trade-offs. So have students explore and explain. More torque equals what? Less speed or vice versa. Start with observation. Let students analyze how robots move before introducing the terminology. So you could do some classroom, showcase where maybe build a simple arm and show that to the student and show them, if you increase the speed on that motor, how does that work? And then tie in the terminology. Use controlled experiments. So going back to that same method, change one variable at the time. Maybe we change the size of the gear, the type of the wheel, we add some weight to it, and observe the impact. Require students to collect data. Students should measure and record their data, put that in their engineering notebook so that they have some reason to improve their design through their iterations. Use that data to drive their explanations. So ask them questions like, what does your data show? How does that explain your design choice? And of course, we're going to end that with our application. So they're going to apply those findings to a final challenge or project or competition. Then we also give you about a page and a half for each standard of instructional resources. So here's some examples. And don't think just because you're not teaching a certain system or a certain lesson that it might not be useful. So the first example from First Lego League, I may not have Legos and whatnot, but I see that that's engineering notebook and documentation resources. So I could go to that link and I might be able to steal that content and adapt it and change it to use in my own classroom. The IT International Technology and Engineering Educators Association, those CT safety resources, those are free and available for everyone. You have PowerPoints, safety videos, safety posters you can print out. Even if you need forms for parents to sign and teachers and incident reports, if your school doesn't have that stuff, they have templates that you can download for all of that. We do try to include some lessons from some of our different partners. Some days you just don't have a lesson or you don't know where to start. We try to include those. You can totally use those, build upon those, maybe even use it as an emergency lesson plan. And then we also try to include some general resources, such as posters you can print out, handouts, YouTube videos, different things that support you so that you can turn those tools into meaningful learning experiences. So that's kind of what you'll see in the curriculum guide itself. Now, next year during the pilot, we're going to have some different supports to help you and your CTE leadership during the pilot year. So we have sent the standards to First Robotics, Lego Education, Parallax, Pitsco, Rev Robotics, and Vex Robotics. As soon as they get that content back, we will post that on our Moodle, or this summer we're launching the new CTE Hub, which is on Canvas. That'll be something we launch at summer conference. So whenever those come back to me, I'll post those there. We also have a pathway teacher lead. So applications for this position will launch in April. So next month. So if you're a teacher that's really into robotics and you think that you could support robotics at the middle grades and at the high school level, feel free to apply. You will need the support of your principal and your CTE director. It is a paid position. It is a part-time contract. Our new teacher leads will be announced during the summer conference. And our general scope of work, our teacher leads this year, we had some for Adobe and computer science. We're going to add a bunch more. Robotics is one of those. But in general, the Pathway Teacher Lead will host a monthly statewide PLC. They will provide professional development during the semester. They'll present at the 2027 summer conference. and they may assist with updates on the course during its transition into standard status. So, um, even if you're not interested in becoming a Pathway Teacher Lead, I want you to reach out to the new Pathway Teacher Lead when they're announced. And go to those meetings, go to those PLC meetings. I know in some of our schools and some of our systems, you may be the only one teaching robotics. The Pathway Teacher Lead is your first point of contact to help you. They are in the classroom every day. Of course, I'm always available, and then Mike Renee, who will be the lead consultant for this, he will be available to assist you guys as well. Now, with all courses launching in pilot status, we will host our check-in meetings and surveys. And I put tentative because it's too early to know what the dates are. We'll post those when the new school year starts. But please try to go to those meetings. And if you can't go to the meetings, at least try to fill out the surveys. We really need the data. If no one answers the survey, our leadership assumes course must be good to go. So I need you to fill out the surveys. If you want changes made, we have to hear from the squeaky wheels. Of course, we have CSIT office hours. Currently this semester, it's held almost every Tuesday. There may be a Tuesday we skip every now and then, but we have the link there. It starts at 4 o'clock. You can come in, you can ask us questions about anything at all. So that includes this course and any other course you may be teaching. I don't know if it's going to stay on every Tuesday at 4 o'clock next year. So that's why this one is tentative. All right, and then that is the end of our session. I will stop the recording.